Hello, welcome to your OPS 245 Week 10 lecture video. This week we're going to look at virtual networking. So we're going to look at virtual networks, how to manage them, how to modify network interfaces on virtual machines to control what networks they have and what they're connected to. Pretty much everything that you learn, well, pretty much everything you learn in this week, right? All of the concepts apply to physical networks, for the most part, and all of the concepts apply to the cloud as well, which is pretty awesome. Lays a pretty good foundation for you. So, what is a virtual network? A virtual network is a way to create a network using software and protocols. That's what virtual machines are, right? We're virtualizing the hardware. So you don't need physical hardware, you don't need the physical Ethernet cables and NICs. Obviously your host needs those things, right? But your virtual machines don't. They do have virtual emulations of all of those though. However, you don't encounter things like broken cables and stuff like that, right? Because it all just works. It's useful for a couple different things. You can create a virtual network using virtual machines to simulate a real network. And in fact, this is often done in industry. You'll have a development environment and a production environment. And guess what your development environment consists of? Virtual machines and virtual networks. It's a good way of testing things out. And you can configure everything on those virtual machines and those virtual networks to emulate the real configuration. So when you're ready and you've tested and worked out all the bugs, you're ready to deploy on the real servers, your major issues should be minimalized. You can also create a virtual network on top of a physical network, or even spanning many physical networks, which I don't like the term virtual private network here, VPN, because that's something else entirely. But you can have both, right? You can have virtual networks within your physical network to segregate traffic, to isolate resources. I mean, that's how Matrix works. Matrix is just a bunch of VMs. I bet you didn't know that. And you used Matrix for a whole semester. So both of these things are done to safely connect servers together and give you access to specify what parts of the network you want accessible externally, right? Now in Lab 2, you created a virtual network on your C7 host. And in fact, I would go one step farther. You're using another virtual network in VMware, right? That's hosting your CentOS 7, your C7 host VM. That connects you to a real physical network. The software that controls these and how you're getting DHCP addresses without a server, that's all built into your virtual network. So you get IP addresses automatically. That's a common feature in networks. We tend to have DHCP servers for things like that. But usually, when you're dealing with servers, you want to give static IPs, which we're going to touch on in a little bit. And again, I've mentioned a few times, right? I want you to start thinking of yourselves as system administrators, right? As network admins, because that's what you're learning to be. Well, we'll expand on that in a couple slides. Here's what your virtual network currently looks like, right? You've got your C7 host, which is a virtual machine. And it says bridged adapter here. It could be bridged, it could be NAT, doesn't really matter. They do the same thing, more or less. They do it a bit differently, but they have the same effect. And then within that, we have our three virtual machines, CentOS 1, 2, and 3, right? That they operate inside that. C7 host is kind of like a container for them. And they connect to Seneca's virtual network and get out to the internet, the World Wide Web, right? Now, currently, we get IP addresses on those three VMs from the DHCP service that's running in our virtual network in KVM. And that's got some disadvantages, right? You don't have any control over what addresses they get. And also, if there were servers, you would give them static IPs, right? And we're going to start configuring services and treating a couple of those virtual machines as if they were a server. So that's an important thing. So we're gonna deal with that, right? Because DHCP addresses change all the time. That's not great for servers. You want it to be reachable. You want it to have a static IP, so you can usually map that to a domain name using DNS, which we're not going to touch in this course, and then you can access it anywhere all the time because it's never going to change. So we can use static IP addresses. You've done this in Windows, I'm sure. We're going to do it in Linux this week. Static IP addresses are useful because that you know for sure, right, what a particular server has, what IP address it has. You can map a domain name to it if you want. We're not going to do anything with DNS, but we are going to use etc hosts and kind of do something similar. It's kind of the old school way, pre-DNS. That's how it used to work. So in Lab 6, you're going to do this. You're going to assign static IPs to your 3 VMs because it's just a good practice. Now, we're going to use the CIDR notation for our network, and that's the slash notation that you've seen. You should have talked about this in your CSN courses, right? In a lot more detail. The first thing you're going to do is you're going to define your network ID. And you know all about those because you're taking CSN, right? But your network ID is going to be shown in this CIDR notation. We're going to use 192.168.245.0/24, which means those first 3 octets represent the network, right? And this last octet here, that represents hosts on the networks. Hosts on the network. So there's 2 IPs in there that we can't use. Our network ID, which is good, this one right here, right? And our broadcast, which is 255 in the last octet in this particular case. So that means we have this range of IPs available to us, right? Based on the subnet mask. 192.168.245.1 through 192.168.245.254. But we actually don't have that first one because that very first usable IP is reserved for the default gateway, your virtual NIC that exists associated with that network on your C7 host. So we actually have one less IP. I'm not going to create one. But you're going to create one in the lab, right? It's pretty easy. You just you go to your virtual network, edit virtual network, and there you go. You can do everything. I'll walk you through it in the lab. Now, one of the main differences between our new virtual network that we've added and the default one that you've been using, it's not going to have a DHCP server. And that's okay, because we're going to treat our virtual machines as if they're servers, and we're going to assign them static IPs, like we already talked about, right? So when they first come up, they're not going to have any IP address, they're not going to have any access to the internet, they're going to need static IPs. And that's what we're going to do. Once we assign a static IP, it's going to have that IP forever, it's not going to change. That's how you do things with servers. When you're configuring a static IP, it requires the following things, and sometimes a few more parameters, right? It needs an IP address that's unique to the server. It needs a subnet mask, right? The network address, or to determine what the network address, that's the badly worded slide. It needs a subnet mask so it knows how to read that IP address, right? It knows what portion is unique to the network and what portion is unique to hosts. It needs a default gateway, so it knows where to send traffic to get outside of the network. And it's going to need DNS servers, so it knows where to send DNS requests. We're going to use the IP of our virtual network for our virtual NIC on the host, .1 as our DNS server. Now, to configure these, you just use Vi or Nano. Take your pick in text editor. Vi's a bit better, right? And you edit a file that exists in etc sysconfig network scripts. Now, this is deprecated in future versions of CentOS and Red Hat, right? This is how it works in CentOS 7, though. Just throwing that out there because when you learn other operating systems, this might be in a different place. You know it's an important file because it's in etc, etc, right? Sysconfig network scripts, and then within there, if you do an ls, you're going to see a bunch of interface files. They start with ifcfg, short for interface configuration, or interface config, dash, and then the name of the interface. So it could be ETH0, it could be ENS3, or ENS33, or something like that, right? And if you don't see one there, you can create one, that's okay. Now, that particular file, once you edit it, might have a bunch of stuff in it. It might need some things added to it. It might not have anything in it. It should have something, though. It takes a bunch of parameters. Hardware address, HWADDR, that's the MAC address. And that actually has to match what's on the system. Even though it's a virtual NIC, it still has a MAC address, right? So that has to match it. Device also has to match what's on the system. These two things are how, when you bring the interface up, Network Manager knows what NIC to apply those settings to. Boot proto is short for boot protocol. This could be DHCP, none, or static. I think usually I just leave it out, but you can set it to static. If you leave it out and you set a static IP, it's just going to work. On boot takes the options yes or no. Yes brings the interface up when the machine boots, which you kind of want that happening, right? So usually you set that to yes. IPADDR, that's the IP address, right? And then the IP address. Prefix, so you can give it the CIDR notation prefix, the /24. It also takes the subnet mask. I think it's actually called subnet mask, if I recall correctly. I haven't had to do it in quite a long time. And then you put the dotted decimal notation. Just use the prefix or whatever the lab tells you. You'll be fine. Gateway, well, that's your default gateway, right? That's going to be the IP address for your default gateway. And DNS, it takes up to 3 DNS servers. And these are written to etcresolve.conf. That's your DNS resolver library locally when the interface comes up. So you want that, right? You want all of those things. Once you've changed the config file, just like when you configure a service, you have to tell the server to use the new information in the file because it's changed. So you bring the interface down. You're going to need sudo for this. Sudo ifdown, and then the interface name. You can stick this on one line, semicolon, sudo ifup, and then the interface name. Now, these particular commands, ifdown and ifup, they're deprecated. They actually don't work in newer versions of Red Hat. So, the other commands that you could use to do these are IP link set dev, and then the name of the device, and then whether you want it up or down. It's a bit longer, but that's the newer syntax, and you're going to want to try to get comfortable with those. I always default to ifdown and ifup because that's what I learned, but the IP commands, those are the ones you want to learn. Now once everything's configured, you're going to want to troubleshoot things. And this concept is true in any operating system, in Cisco, in Linux, in Windows. It doesn't matter, in Mac OS. You make a change, you want to test it. We've changed the network, so we're going to want to test it. We're going to use ping, which is available in all of those operating systems I just mentioned, including Linux. Ping will tell you if the target is reachable or not, right? You could use a trace route as well. If you want to see what your IP address and interface settings are, you can use IPA, right? We've done that before. ARP-N will give you the ARP table, which gives you your mappings of MAC addresses to IP addresses. And SS-NAUTP. It's a lot of options there on one line, right? That'll give you a list of the ports that are currently available. So you could use any or all of these depending on what you're doing. These are useful commands to remember for troubleshooting that you're going to come back to time and time again. Once you've set them up with static IP addresses, since they won't change, we can set up hostname resolution. In a production environment, you would probably configure DNS at this point, right? But we're going to do it a really old school way that predates DNS. Just because it's simple. DNS requires setting up a server, it's a bit more complicated, and it's outside of the scope of this course. But you can actually, this is what we used to do before DNS. I say we, I never did this, I just know it exists. You can set up a file in Linux. There's also one that exists in Windows. I don't know if it's still there in the latest version of Windows, but it was as of Windows 7, it was still there. I think it's there in Windows 10 as well. I haven't looked, I haven't used Windows 10 as much. That will give you, this file will give you local hostname mapping without needing a DNS server. That's in etc. Again, you know it's an important file because it's in the etc directory. etc hosts is the file. And within there, you can have a space-separated list of IP addresses and their host names that you want them mapped to on one entry per line. This is actually how things worked before DNS. Everybody would keep a local copy of their host's file, and anytime they made a change to their internal network, they would send that file out to the other people on the, what was ARPANET then, right? On the internet. Now you can see why this doesn't work now, right? Back when this was done, the internet consisted of like 10 servers, and they were the size of a house, right? Like it was sort of maintainable then. But as things grew, people realized that wasn't maintainable, and they created DNS back in 1983. I was 2 years old. Most of you were not even remotely born yet, right? So go in, edit that file. You're going to need sudo for that, right? Edit it with vi or nano. Just saying, you could use either. Stick those in. It'll actually be those IP addresses. And save and quit. And now, from the server that you've done that on, it could be C7 host, could be CentOS 1, it could be CentOS 2. I don't remember where the lab has you do it. But from that particular server, you can try to ping each of those servers by their host name. But this is the big drawback to this, right? It doesn't sync across devices. So you have to set this up. If you want it to work entirely within your network, which is C7 host, CentOS 1, CentOS 2, CentOS 3, you have to do this 4 times. You can see why we don't do it this way anymore, right? This does not scale well at all. If you've got a larger network, you'd have to do this on every single device in your network. So it's okay for small networks. It's really like you're just going to have DNS, which you're going to learn how to do in next semester. You're going to learn a bit with DNS. And you'll have learned some stuff in your Windows courses on DNS as well, right? DNS is one of those cool things that the concepts translate across operating systems. So if you can do it in Linux, you can do it in Windows and vice versa. The files and where they're located are slightly different, and the implementation is a bit different, but the syntax for those files and the concepts and how it works and the different types of records, that all works the same. So you're going to learn that next semester. We're just going to use the old school, really old school, right? etc hosts file. In Windows, I don't remember where it is, but there is a hosts.txt file. It used to be in System32, I think. I haven't looked at it in a very, very long time. So, with that in mind, that's it for the theory for this week. However, I am going to pull up your Lab 2 Assignment 2 specification and go through it with you, because I promised you I'd do that. So, see you in, well, it'll be seconds for you, it'll be a couple minutes for me, because I'm going to pull it up. Alright, so as promised, Assignment 2. This should be released by now, because it released on, well, I'm recording this on Sunday evening, and it released at 12 o'clock a.m. this morning. I think I went through this with you last week. But if you weren't there or whatever, I'm just doing it again, right? Two things in the Assignment 2 folder. There's the Mark script, which you're going to run when you're done. It's a bit different than the Mark scripts you've run so far. You're going to actually copy it. You could just use SCP, right? And copy it to CentOS 3, where you're going to be doing this configuration. Run it there. It'll output a text file. It'll ask you a couple things before it outputs the text file. And then you can just copy that to your host and stick it in the submission folder, which is somewhere down here, I think in week 13. Yeah, there it is, week 13. Which brings the first thing before I open the PDF. When is it due? August 11th, which is a Friday, at 11:59 p.m. So you've got a bit of time to do this. That's not so bad. Let's look at what you're going to do. Let's make this bigger. That actually didn't really help that much. So I've given you just a fancy auto-generated table of contents that'll take you to the different pages. The nice thing is you can click on these. So if you got up to Apache done later and you want to go back later, you can just click and go. So in Assignment 2, you're going to configure what we call in industry a LAMP stack. It's an acronym that originally stood for Linux, Apache, MySQL, and PHP. It's super common in industry. It's used all over the place. In fact, newer technologies that have come along to replace elements of the LAMP stack pick their name based on the letter of the acronym they're fulfilling. So like MariaDB and MongoDB, which are a bit newer than MySQL. Perl and Python. Python's a bit newer and more trendy, but we're going to use PHP. Honestly, PHP powers like 82% of the internet that we know of. So it's pretty embedded at this point. It's been around for a long time, but it's pretty embedded. Now this is a common platform for hosting web-based applications. And we're going to use this to host a web-based application. Of course, right? We're going to install and configure WordPress, which is a free open source content management system. Now you can just use WordPress. You can get a WordPress account and host your own blog on WordPress.com or .org or whatever it is. But this is a better way, right? So this is worth 15% of your grade. I just talked about the due date, but it says C Blackboard, right? Because I just talked about it. To submit this, you're going to submit a bunch of screenshots, and you're going to submit the output from that script. I think mostly the output from that script and 2 screenshots, I think it is. You're going to configure 2 services in this assignment. You're going to configure a database server and a web server. You're going to install and use WordPress, and it's going to connect everything with PHP. That's what PHP does. WordPress is built on PHP. Honestly, a lot of stuff on the internet is built on PHP. Facebook, as far as I know, is built on PHP. And you're also going to learn how to configure your firewall to give you more security. And you're probably thinking, well, why the hell do I have to configure my firewall? Because this is just a virtual machine, and it's on my hard drive, and nobody gives a shit. Nobody's going to hack into my stuff. And you're right, nobody's going to hack into your virtual machine because nobody gives a shit. There's nothing there to get into, right? But next semester, you're going to start doing things in the cloud, in AWS. And I want you to start thinking about security. Because there was once upon a time, as a network admin, you didn't have to think about security. You did your configuration, and the security team came along and did their thing, right? And that's still true. There are security experts, or you'll bring in consultants or whatever in your organization to do your thing, or do their thing and analyze your configuration and say, hey, this is broken, fix it. But as a network admin, as we've migrated crap to the cloud, you need to think about security as part of your configuration. Now, it says a note here, right? Do this assignment inside the CentOS 3 virtual machine. Because if anything goes wrong and you don't have a backup, that's the easiest one to restore, and we haven't done much on it. That's why I'm making you use CentOS 3. And back in Lab 4, you may have missed this, but it told you to create your user in CentOS 3. So like my name, right? Or Atuur's, we've got our names in here. Create a user for yourself on that VM if you don't already have one. Now, while you're doing this assignment, you're going to want to take regular backups of that CentOS 3 VM. Because if it breaks in like the last week of the course and you can't submit everything, oh well, right? Have backups and stick them on a USB. Because if everything gets broken, you could reinstall a new operating system on the host, recreate everything, and then restore your virtual machine. So keep backups because that's a good idea. Now, when we get to the instructions, which we're going to look at now, I didn't necessarily give you step-by-step instructions on how to do all of these things. I gave you things to do. For the newer things that you won't have done yet, and there's some things in here that you will not have done yet because they're in labs that we haven't done yet, but you're going to cover them in the next few labs. Honestly, Lab 6 and 7 give you, up to the end of Lab 7, give you all of the tools you need to do this assignment. And you're going to want to do this before you do Lab 8 because Lab 8 messes up your network a bit. So update your system before you begin, right? It says right here, sudo yum-y update, right? Install the following packages. And I gave you a list of packages to install and a description about what they do. So you're going to install the Apache software, that's HTTPD, in Red Hat-based distributions anyway. Debian-based distributions call it something else. PHP, so that's the server software that's going to allow you to run WordPress. PHP MySQL, that's an extension for PHP to connect to databases such as MySQL, but MariaDB and MongoDB use the same syntax. So everything that works with MySQL works with them too. MariaDB Server, that's the database server software. You're going to install and configure that as well. So you have to have it installed here. And we're using MariaDB because it's a little more modern and it has some cool features in it. We're not really using the cool features, but it's a little more modern. So now on to configuring Apache. Start the service using systemctl and make sure it starts on boot. So sudo systemctl start HTTPD and sudo systemctl enable HTTPD, right? You're going to want to try connecting to your web server. There is a default Apache web page there. You can test this using links from the command line. You can also test it from your host using Firefox with the IP address for CentOS 3, which we just finished talking about giving CentOS 3 a static IP. You can see why you want to do Lab 6 and 7 first, right? You should see the Apache test page. Now there's a default Apache test page that's a little different for every single Linux distribution, but you're going to see one. If you don't see one, don't like panic, right? It could be blocked because your firewall's blocking access to it. So you're going to need to configure your firewall, IP tables, to allow incoming traffic. And to figure out what port you're going to use, I didn't tell you what port you're going to use, right? It's HTTP traffic, which you could look up on the internet. Or you could just look in this file, etc services. It has a list of all of the services and their default ports. and we're using the default port for Apache, so that's okay. So just grep HTTP. That first one that comes up is like I tried this, right? I told you the required port is the first one listed. I'm not going to tell you what it is. Look it up. You might want to pipe that output to head to see the top list, or tail to see the bottom of the list, or less or more to scroll through it. Whatever you want, right? It's basic ULI stuff. Then we're going to configure. We're done with Apache for the moment. Next, we're going to configure MariaDB. So start and enable it. You might get some messages after starting it for the first time. Don't worry about it too much. It's going to talk about like passwords and stuff. We're going to set everything using the MySQL secure installation script, which works with MariaDB and MongoDB as well. So run that with sudo, and you're going to get prompts on screen to configure all of these things, right? Set a root password, set it to your Seneca username, and use the things suggested in the lab, or in the lab in the assignment. That's not an ideal password for a production environment that's available on the internet, right? But again, this is your virtual machine. It's a development environment, and we want to make sure that if you have problems, you can get back into this. You don't want to have to redo stuff that you've already done. So set it to something you're going to remember, like your Seneca username. Say yes to remove anonymous users. Say yes to disallow root login remotely. That's a good way of securing your server a little bit. Remove the test database and access to it. There is a test one in there. You want to get rid of it. And then reload the privilege tables, which reloads all, will configure all of the settings that you've just changed, right? They apply it to the existing databases. And then set up a dedicated WordPress user. And you could download WordPress here, or just do it later. Honestly, just do it later. But when you're downloading WordPress, make sure you use the package that's listed here. Don't get the newest one. Newer packages, newer versions of WordPress don't work with CentOS 7. So use this one. So all of these things here, you're going to set the username, or they're down below, right? You're going to set the username for the admin to root, the database name to my blog, the WordPress username to your Seneca username, and the password to your Seneca username, and you're going to use localhost for your host name. So connect to your database after you've got it running, mysql-h localhost-u root-p, and type your password. Then we're going to create the database. I give you all of the syntax here that you need. Create database, my blog. There's a missing semicolon there. Put the semicolon in. Apparently I missed that. Looks like there's a couple missing semicolons. You need a semicolon at the end of each command. It's a minor thing. You can fix it. Create the new user. So you're going to change where it says WordPress username in the command. Make that your Seneca username. So create user, your username at localhost identified by password. Now, whatever you put in here in the quotes is your password in plain text, which should be your Seneca username, right? And then grant the privileges to that new user for everything on the database. So grant all privileges on myblog.star to your username at localhost identified by and your password again. And then reload the privilege tables by flush privileges. And then you're going to want to configure IP tables, your firewall, to allow MySQL and SSH. And I don't tell you the ports, but again, grep there to the first ones that come up. So that's your database done. We've done Apache, we've done the database, we've got everything else we need, more or less. And then you're going to download and install WordPress. So you can download it there. There's a link here. Extract it to var www.html. It's a tar.gz, so you should know how to extract that by the time you're doing this assignment, right? You're going to want to allow Apache access to those files. So you're going to need to use chown and chgroup with the -r option on that directory to make Apache the owner and group for every file inside that directory, right? And then you can check and see if it works, right? So just open that URL, http:// we're not configuring HTTPS, so it's just going to be HTTP, CentOS3/WordPress. You might get an error, so you can just copy the WordPress config sample file, rename it to wordpressconfig.php and edit it. Put your database name, database user, and password in with the ones you created there, right? And don't use the root account. Use the user that you created specifically for this. That's why you created this user. And then you should see the welcome when you reload in the browser. Just refresh. You should see the WordPress welcome setup page. And if you closed it, just reopen it. So just walk through that. At this point, everything else is graphical in your browser, right? You're operating using WordPress and your LAMP stack. So set your name's blog. So OPS2 should say 245 there, right? Your name's blog. Set the password to your Seneca ID. Set the email to your Seneca email address. Click Install WordPress. You'll see a success message. We've done everything. This assignment shouldn't take you super long. And then you're going to write 2 blog posts. One, tell me what Apache, PHP, MySQL, and WordPress are, and talk about problems you encountered during the installation and how you fixed them, major and minor. This is an individual assignment, but there's nothing stopping you from sitting beside somebody you work with well within class and doing this together, right? You work on yours, they work on theirs, and when you get stuck, you help one another out. That's a great way to work on things, and I encourage that. Don't copy paste from the internet, right? That's not a good way of working on things. Write a second blog post. Talk about your whether you're ready for the exam or not. List the material you're strong on. List the material you don't think you're so strong on. Talk about any topics that you want me to address during the review. I'll try to look at these and actually do that. But even if I don't, you can bring these as a list and I can talk about them then, right? And it makes you start to think about it. It makes you start to prepare for that because your exam is coming up. It's 3 weeks away. Well, it's 3 weeks after this week, right? We've got 3 full weeks now, 4 full weeks right now because it's Sunday, but I don't know when you're watching this. Hopefully you're watching it before Tuesday when we have class. Just saying. Make your post look good. Use decent English. Headings, you could use bulleted or numbered lists. Everything's graphical with WordPress, so it's actually pretty easy to do. And then you're going to submit it to get some marks. So you're going to run that check script in your CentOS 3 VM. You're going to have to SCP the check script in, run it, and then copy it back. Copy the file output back to your host so you can upload it. And if you need help in class, I'll help you do this. It's not hard. I'll help you do this part. So you're going to upload the output. It's going to be called a2output.txt. Upload that to the assignment 2 folder on Blackboard. And you're going to take 2 screenshots. One showing your first blog post. One showing your second blog post. That's the proof that you actually did it. Aside from this, that's going to show me that everything's running. And you're going to get some marks. Now what are you going to get marks on? Remember that this is 15%, right? You installed the packages, 1 mark. Apache's running and configured, 3 marks. MySQL is configured, 3 marks and running. WordPress was extracted and in the right place, 1 mark. It's been set up correctly, 2 marks. You accessed it in Firefox, 1 mark. And you're doing it using local hostname resolution, which we just talked about. You're going to do that this week, right? 2 marks. IP tables has been configured, 3 marks. 1 mark for each of your blog posts, and 2 marks for submitting it correctly. It's out of 20. That's not that bad. So everything you need is here. I can go over this with you in class if you want. The check script is literally right here. It's called Mark A2, and the submission is in week 13. Assignment 2, you just click there, add your stuff, you're good to go. That's it for assignment 2. That doesn't sound too bad, does it? So, quick reminder, because I didn't remind you about this. Quiz 5 is available, so you might want to go do that. And it's available till July 24th, which is next Monday at 11:59 p.m. We have assignment 2 to work on. We're going to do lab 6 this week. We're going to do lab 7 next week. Everything you need to do assignment 2 is, all the knowledge is covered this week and next week. So you could start working on assignment 2 the end of next week. You could start working on it this week, right? You can do some of the stuff, you just can't do all of the stuff. And it still gives you 2 weeks to get it in. You got lots of time. With all that in mind, I've talked a lot today. Take care, be safe. I will see you in class this week in the lab, and I'll help you with any problems you're having there. I hope you have a great week. Bye for now.